The goal of this video to introduce you amplitude, frequency, phase shift, and period for any trigonometric function. So based on the example of sine. So A is an amplitude, B is a frequency, alpha is phase shift. If I write down y is equal sine x, let me leave some space here, equals sine x, that means my sine has amplitude 1, my x has frequency 1, and phase shift is 0. And that's how we get just sine x. Okay? All right. So moving to this picture, it's right here. So if you look at this orange color, this sine x, and here it's written sine x, it's right here, orange color. So this is our sine x with amplitude is equal 1. And obviously negative from 1 to negative 1 based on unit circle, right? It's running from negative 1 to 1. Okay. Phase shifting is 0. That's why it starts from 0. And what else we had there? Frequency. Frequency is also 1. So which means one regular, right here we have sine for one period 2 pi will fit on this graph. And it just right here. So you see here 360. So sine x, I showed in my video when I was showing explaining how to build sine x, we saw that it's 90 degrees. Sine x is going to equal 1. And indeed, if you imagine unit circle at the point where y is, sine x, because it's represented by y, is equal 1, right? Okay, at the point of 180 degrees, 1 pi, sine x, which is y, is equal 0, right? At the point of 270 degrees, which is 3 over 2 pi, is equal negative 1. And back to 360, it's 2 pi. And this is what we call 1 period. So for the sine x, for this sine x that we have, the period is 2 pi, which means x, angle x, it's going to be greater equal 0, less equal 2 pi. Here we have. Now let's learn how to build the sine x with the phase more than 1. In sine x we have phase 1. Now let's, not phase, I'm sorry, frequency 1. Then now let's use higher frequency that is greater than 1 or lower frequency that is less than 1. Okay, so here we take b is greater than 1 frequency, which we are taking sine to x. Blue color here written sine to x. So how did I build this? Where from I came? Step 1, what we're going to do, first of all, to calculate how much will be the period for sine to x. As a shortcut, I can tell you if x has from 0, just x itself, has period from 0 to 2 pi, right here, then 2x meaning and x meaning 1x, so which means 1 full x period from 0 to 360, it's going to fit in there, 1 wave, okay? Then 2x, meaning you have to fit in there 2 waves, 2 sine x's, which is, look, This our 360. Orange color is, look, one wave. Orange comes one the positive, and then comes down one negative, right? Now 2x, we are going to fit two waves in the 360 because we have two x's. So blue color is our one wave, and then black color is another wave. Why I shaded in two different colors? Because to find the period, okay, we fit two waves in 360 degrees. But what is the period? You cannot have the same period as sine x, right? If x is equal, a period of x greater than 0 and less than 2 pi, then period for 2x, it's going to be greater than 0, less than 2 pi. Let's find from here how much will be the x, period for x. So we divide by 2. Here it is. And since we have inequalities, we divide and here and here. So we end up with, so this 2 is gone, canceling with it, and we get x is equal, greater equal 0, less equal pi. What did we get? When we have 2x, so our period shrinks to 1 pi. This is why here it is 1 pi. I built with blue color that end at 1 pi, 180 degrees. Okay, and the second wave, it fits to 2 pi, our unit circle at this point. But the period for the sine 2x, okay, let me write down. Since we are building the graph sine 2x, period is going to be equal 1 pi. Okay, so here it is. Next wave, it's just a continuation. Based on period, it will go another pi, and then it can continue, wave go another pi, because waves, which is represented by sine, cosine, can run from negative infinity to positive infinity. It's just we calculate the period for the length for the 1 pi, meaning angle for 1 pi, which is going to be 180 degrees. All right, so that was 2 pi. Now let's look, what if we have b is less than 1? When we take sine half of x, so what do we get here? If for sine x, our x is, let me look like that so you can see the whole picture. If x is greater equals 0, less equal to pi, then half of x, that is greater equals 0, less equal to pi, we divide by half. So this half and this half is gone. So if you divide 2 pi by 1/2, you practically flip, right? This second fraction 1/2, you end up with multiplying by 2. And this is where you get your period, 4 pi. So when b is less than 1, then your sine wave is stretching. If it's greater than 1, then sine x is shrinking. Let's see. So one period is 4 pi. If one period is 4 pi, then in 36, 2 pi is going to fit only half of the wave, correct? So here it is, 360 degrees. This orange color dashes, it's sine x, you can see. And from 0 to 2 pi or 360 degrees, you can fit only one wave. So to build the whole this 4 pi, you have to go another 2 pi, which will be 4 pi altogether. So, but because we are building within 360 degrees, we are building our graphs within 360 degrees. That's why I did not continue. I just squeezed in 360 degrees. We are working with from 0 to 360 degrees, okay? Similar way, I can show you cosine x. So this orange colored dashes, we see it's a cosine x. Oops. Is cosine x. Okay, and that's this one. Cosine x. Now to build, and cosine x also has period 2 pi, right? Just like sine x has period 2 pi. If we take cosine 2x, it's same way, it's gonna go only the one wave and fit in 1 pi. Why? Because of the same calculations here, because period will become, for cosine 2x, period will become 1 pi. So the period for the same frequency, be it sine, be it cosine, is exactly the same. We have here 2x, period is pi. We have here cosine also 2x, period is pi. If we would have sine 1x, period is 2 pi. Cosine 1x, period is 1 pi. Okay, and the second pi, because we are a second half at the second wave, because we are working between 0 and 360 degrees, that's why I ended up drawing the second wave also with the black color. And that's why I put two different colors. With green color shows the period, which is how much is fit in period. It's a one wave, right? And the second wave, it's just the second wave to 360. And remember what I said, if you have 2x, that means you fit two waves in 360. If you have 4x, then you're gonna fit 4 waves in 360. If you have 8x, then you fit 8 waves in 360. And accordingly, the period will be shortened by 8 times, right? By as many times as your will decrease the period, by as many times as your frequency is. Okay, next, cosine half a x, just like sine, it's gonna become just like sine, it's gonna become the period is gonna become 4 pi, because once we divide half a x, once we divide by 1/2, we divide here by 1/2, exactly same way, just like sine, we get period 4 pi, which means within 360 degrees, we will fit only half of wave. Okay? Okay, so we looked for frequency B that is greater than 1, less than 1, and equal to 1. We already know it's a graph sine x, or it's a graph cosine x. Now what if this B is negative, less than 1? Let's assume I will take, for example, y is equal sine how much? Let's say negative 2x. Okay? How are we gonna build this? Okay, so our b is negative 2, correct? So we know that sine is an odd function, which means sine negative x is equal negative sine x, and that's where we're gonna use this odd property of sine, which means sine negative 2x I will write down as a negative sine 2x. All right, so when we have 2x, that means within this 2 pi period, we are going to fit 2 waves, right? Instead of 1. All right. Let's see. Wish me good luck so I can draw it normally, so I don't get messed up. All right. So with these black dashes, I have sine x. Now we are going with sine 2x right now. And then I'll tell you with negative what we're gonna do. All right. So it's gonna go like that. Coming as a negative degree, 90 degrees, it's gonna cross as a 0. And then come here, touch -1, and come here. So something like that. Okay, this is my half a pi. This is my pi. So we fit 1 pi, correct? So the rest here is 3/2 pi. This piece. So if I go, I'm going to continue with black color because it's going in 360. It's going to be fitting 2 waves, but since our 1 pi is our period based on this calculation, right? No, not this one here, this one. Yeah, I can write down here. I don't have to go through. So 2x is greater or equal 0, less equal 2 pi. So we need 1x. So I divide therefore by 2, by 2, by 2. This is gone with this. And what do I get? X is going to be greater or equal 0, less equal pi. And that's how I get that my pi is my period. Okay, let me go now with a second wave. There we go. Here it is. Go thicker. So this is my second wave. Okay. So, but we have negative sine 2x. And negative, we are getting close to our amplitude. Remember the coefficient that stands in front of sine? It's right here with this red color. It's our amplitude, which is in this case, my amplitude is going to be negative. Amplitude, okay, frequency is changing horizontally, okay? Frequency is changing horizontally, shrinking or stretching, so it's changing horizontally. Amplitude is changing vertically, up or down, okay? So if we have negative, that means we are going down, so it's going to be every value of y here that we have positive, it's going to become negative, which means, so negative sine 2x, I'm going to build mirroring the sine 2x, mirroring towards our x-axis. Let me show you. So here we have at positive, this blue color and black. Now to build the negative one, I'm going to go the opposite direction. It's going to come this way. It's not good. Let me go dashes and then I can come. So see, blue one here is -1. That means red one on +1. And then at the 0, they both meet each other. And then I'm going down again. So the black one here is at this point. So a red one, it's going to be down at this point, at its -1. Zeros are stays the same. Okay, and here we go. We have negative. So this graph, it's going to look like this. There we go. So this is going to be negative sine 2x. Okay? All right. Now let's do practicing more amplitude. We just started with -1. Let's go to now, instead of just negative sine x, let's build free sine 2x. Here it is. Y is equal free sine 2x. So what is the deal here? Look, when it's come to amplitude, amplitude doesn't change the period at all. Whatever period sine has, be it x, be it 2x, be it 5x, it stays the same. Like I said, amplitude is changing up and down. Okay? Period is running horizontally on x-axis. Amplitude is running vertically on y-axis. So this is, here we have our sine x with these black dashes, right? Sine 2x actually. So, and we have two waves fitting in 360 and one wave with period of 180 degrees. It's finishing here. Now we need free sine 2x. So when we have sine x, remember, sine 2x, doesn't matter, but I want to take what we have, sine 2x. Our amplitude meaning 1. But here we have free. So which means, look here, 1, 2, 3. So these black waves we are taking and stretching by to positive 3 and to negative 3. And we didn't shift it anything. We just pulled up and pulled down. And this dark blue one is free sine 2x. Now, the period, we already know the x is between 0 and 360. Then sine 2x, I mean 2x, it's going to be greater equal 0, less equal 360. If we divide by 2, I already did it, but it's never hurt to repeat itself again. So it's going to be x is greater than 0, less than 180. All right. So this is, the blue color is y is equal sine 2x. So now let's look cosine. 4 cosine 2x. 4 cosine, why am I building on 2x? Because we started with 2x and I keep expanding this 2x. And then if you want, I can build the half an x also. So 4 cosine 2x with this dashes here. This is cosine x, right? Here it goes, cosine x. 2x, cosine 2x. That's why in 360 we have two waves. Now we need 4 cosine 2x. So our amplitude is going to stretch till now it was 1, right? Here is 1 and negative 1. Now it's moving till 4 right here. From positive 4 to negative 4. So we don't shift anything. We just take and stretch it. 1 become here. This 1 become positive 4. And negative 1 become negative 4 here. And you keep going. So this is your amplitude. Okay? Now, on this graph, see, I prepared it so it would be relatively nicer looking graph. I prepared here the case cosine 4x. So if we have cosine 4x, what does that mean? For the period, because frequency definitely affects period, and your 4 is your frequency, right? So 4x greater equal 0, less equal 2 pi. So to find 1 pi, I'm going to divide by 4 here, divide by 4 here, and divide by 4 here. So what we are getting here, x greater equal 0 and less equal half a pi, right? Pi over 2. This is 1, this is 2. So we have one wave fitting in 1 pi. Here it is, since it's cosine, it's starting up here, coming down and then come up. This is your half a pi right here. Okay? So this is your, this is how it looks like, cosine. Right? So it's one wave till half a pi. But since we have 4x and we are interested in 360 degrees, it's a unit circle, 360, then 4 shows you're gonna fit 4 waves in 360 degrees or into pi. Let's see. This is 1, 2 waves, 3 waves, and this is 4. The first one is a half wave here and halfway here. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3 waves, and 1 half here, 1 half here. You got 4 waves. Okay? That's how you gonna build frequency and amplitude, obviously. All right, let's do now another amplitude. Instead of 1, build how much you wanna build. I have here sine x. This is sine x. So here we have 3 sine x. So let's do 2 sine x. Okay, let's build 2 sine x. Which means instead of 1, I'm going to have 2, positive 2 and negative 2. So the graph is going to go like this. It's going to go same point, maximum and minimum, but it's going to go higher where 2 is. Right? So it will go, okay. Come down and then come all the way here. And this is gonna be your sine 2x, 2 sine x. I hope you are doing good. Okay, so next, let's explore. So we looked into amplitude. We looked into frequency. Now we are moving to phase shift. Moving to phase shift. Here it is. We have sine x minus 60. So I put here schedule. Y is equal sine x minus 60. Why schedule? Because x minus 60, x plus 45, x minus 120, it's either the second trig function is falling behind or it's leading, getting ahead. So that's what you use when you wanna schedule giving the let's say electricity, because electricity it's a trig function, right? Giving electricity a little bit later with delay. Or sound, when you are increasing sound, actually that's a good idea. Let me bring example. When you are turning the handle of some radio, let's say, or any music, so you are turning sound, it's getting higher, right? That means you increase the amplitude. When it's going louder, amplitude is going higher. If it's turning down, amplitude is going lower. So if you are working, editing some music, if you wanna it go faster, sometime like cartoon music moving or people working faster, that's a frequency. That is a frequency change. If you're going faster, then within one period you are fitting several waves. If you want to go slower, then see here in one period if half a period, you have one wave only. So one full wave, here it's fitting in 4 pi in this case, right? Because it's a half of x, so which means half of x in 360 will fit only half of the wave. So that's where you can use it there. It's used in astronomy and used in medical areas where sine, cosine, oscillograph is running, and so on. So now let's learn when you are, let's say, giving some electricity or some other waves you are giving with delay. All right, so let's, we are looking at sine x minus 60 degrees. So with black color here, we have sine x. Here it is, okay? Now, we need to build sine x minus 6. So how are we going to do? How I'm going to build this 60 degrees delay? So I want to know when x is at 0, this original one is here, where is going to be x minus 60? So at any point on x axis, we are going to have our y0, correct? So if I assign that sine, if I put sine x minus 60, sine x minus 60 is equal 0. So I want to know at what x sine is going to be 60. So that means x minus 60, it's going to be 0, which means at x is equal 60, your y is going to be 0, which means this is our 60. So you take this shift, x plus whatever angle or x minus whatever angle, you assign to 0. And that will tell you which direction you are going to shift, because therefore, as a rule, when you have minus some angle shifting, then you are moving towards positive. When you have plus shifting some angle, then you are moving towards negative. Just like in quadratic, graphing quadratic expression. So remember when we built, let's say, let me do here drafting. When we build y is equal x, let's say minus 2 squared, then you shift x by positive 2. But if you have x plus 2 squared, you shift by negative 2. X is usually shifted toward to opposite direction by this basic reason that when you assign x and attach to it term 0, then you get the opposite sign. All right? But y is changing plus and minus the way it's given. If it's plus, then you move up. If it's minus, then you move down. And that is your, we will explore that also. All right. So whenever my sine x is equal 0, then x sine x minus 60, it's starting at 60. So this is your 90 degrees for sine x, and this is your 60 degrees for sine x. This new sine x minus 60, okay? And difference between this and this, it's going to be 60 degrees because they are shifted from each other, okay? So, which means this point will be how much? 180, because this piece is going to be 60, right? Difference. So 180 plus 60, this is going to be 240, right? So if I continue this and this one, so 360, this piece is going to be 60 difference. This is going to be 60, correct? All right. So if I bring down this one, so 90 degrees moved by 60, guess how much it's going to be here? 90 plus 60, 150 degrees. Okay? Now if we take cosine, but the period, how much is going to be period for this one? Let's do the period. What is amplitude? Amplitude is going to be 1. Okay, the amplitude is gonna be 1 because we have sine x minus 60 is 1. Frequency is 1. That means it's not shrinking, it's not stretching. We just take the one wave and shift to the right or shift to the left. We shift to the left when we have plus angle, and we shift to the right when we have minus angle. Okay, so let's find out the our frequency, our period. So x minus 60 degrees is greater equal 0, less equal 2 pi, right? Or I can put, since we have 60 degrees, I'll put 360. Where is it? 360, right? We make it a little bit thicker so you can see, guys. 360. From here, x, if I move negative 60 here also and here also, because we have two inequalities, right? So you have to treat them equally. So x greater equal 0 plus 60 degrees and less equal 360 plus 60 degrees here. So my x is period is changing from 60 degrees less equal 420 degrees. This is my period. And indeed, look, it's starting from here and going all the way to here. Remember we said this difference is also going to be 60 degrees. So 360 plus 60 is going to be 420. But because we are showing graph only within 360, therefore I am just finishing here this piece. So I can have the full wave in 360. And it stopped right at 360. Somewhere right here. That's why. Otherwise, if you would draw the graph without considering condition 360 degrees, then it's gonna look like this. So if this is your x, sine x, then x minus 60 degrees, it's gonna start from here. And come here. And you can see the period, it starts at 60 and ends in 420 degrees. Okay? The same way, it's going to be cosine x plus 45 degrees. X plus 45 degrees. So, we draw first cosine, which is this black one. Black color is our cosine. Okay, so when we have plus 45, that means we are going to shift towards left. So which means this piece difference, it's going to be shifting to the left, right? This the green color getting ahead. And guess how much is going to be this point? If this is 90 minus 45, it's going to be 45 degrees. If this is 180, so this point will be 180 minus 45. So 135 degrees. And if this is 270 minus 45, 225 degrees, and so on. All right? And we show only till 360. Okay, I hope I made myself clear, I explained well. And in my next video, I'm going to try to use some example where you have the amplitude and phase, the shifting and frequency. So I'll solve a couple of problems, okay? See you in next video.